everybody, and welcome back to Airbus and what's it doing now. Slightly unfamiliar surroundings for you today. I'm up in my study. Been thrown out of the usual briefing room today because we've got some electrical work that's going to be going on a little bit later on. We have a problem with the ring circuit for our lighting downstairs, and every time we turn the fuse on, it trips the whole of the house. So and our fuse board is actually in that same room. So we're upstairs today in my study. I've got a couple of small Novo boards up on the wall which I use for my prep work, and they're too small to really brief on. So this is going to be a slightly different briefing today, where we do a lot of it on the PC, but it'll all make sense a little bit later on. So today we're going to talk about the avionics ventilation, which is not a subject that I really enjoyed. I remember doing this when I was doing command training, and it was just one of those subjects which I kind of glossed over and thought, I'll come back to that. In fairness, it's like anything. Once you start reading it again and you spend sort of 15-20 minutes going over it and some of the reconfigurations, and you sort of imagine it working in your mind, it actually isn't that bad. I'm not going to spend a whole lot of time on it because essentially it's an automatic system which calls the avionics and avionics equipment. We don't touch it for the most part, and our interaction with it is fairly limited. But I thought, as it's part of the air conditioning and pressurization, it would be worth reviewing. So like I say, it's all controlled autonomously, I can say that word now, via the AEVC, which is the Avionics Equipment Ventilation Computer. So we don't really have to get involved in it. We don't have to set it for anything. It kind of manages it all itself. Draws air from the flight deck. It calls the avionics equipment. That's our instrumentation, DUs, air drawn from behind the CB panels, etc. It draws all that air through the flight deck floor. Calls computers, etc. In the avionics bay as well. All this is achieved by a combination of either outside air. I'll show you how that all works. You'll be familiar with the extract fans and the inlet and outlet ports around the aircraft. That's the one as you walk around the left of the airplane by the nose cone. It's sucking air in, and at this time of year, if you're wearing your beanie hat, when you walk around the other side, it blows it off your head. They're those two valves which I'll talk about in a minute. So combination of outside air, a combination of internal air as well, through some swanky heat exchanger. A little bit of air conditioned air is added to it as well, and a series of valves and fans, all dependent on the outside air temperature and whether or not the aircraft's in flight or on the ground. So we'll take a look at the system components. We'll have a look at the system operation, ground and in flight, in its sort of normal operation, and then we'll have a look at the system in abnormal operation. So the fan's not working, or fan low pressure, or indeed the smoke reconfiguration. So that's it from me in terms of what you see of me. You'll be pleased to know it'll all be going PC based this afternoon. So without further ado, let's get into it. Okay guys, so let's get straight into it then. I'm going to bring up the drawing from the FCOM, because it's a really great drawing actually. It's got all the components on there and the various systems of operation. Pretty much what I would draw on the board, so we're not really missing anything here. I said I'd go through the components first and then through sort of normal operations, so I'll talk about those bits and pieces now, and then we can go on to sort of basically how it works. The configuration that you're looking at now, without going into too much detail, is the standard normal operation open circuit configuration, which is how you would normally see the system or how it would be operating on the ground on a normal day. The You'll know this, the system is operating typically because as you do a walk around the airplane on the left hand side, you see that inlet flap that's open, that's sucking air in. You can hear the fan blowing away. And then when you walk around the outside, if you're wearing a hat, a beanie hat in winter, the air being expelled out, that's quite powerful and will normally blow your beanie off. So that's the configuration you'd normally see the aircraft in on the ground. Just to give you some idea. So just going through the components here, you've got a valve here, which is the skin extraction outlet bypass valve. Don't worry too much about the terminology, but basically that's the valve that will allow air in from the avionics bay. We've got a skin heat exchanger here, so there's a liquid that actually flows through this heat exchanger, and like anything, it'll impart warm air, cool it down in order to add cool air to the system. We have the skin exchange isolation valve here, so that would normally be open if the skin heat exchanger is working. And then coming down the bottom here, I mentioned we've got this skin air inlet valve. That's the valve which opens the air to be drawn in from outside of the airplane on the left. On the right hand side, you've got the skin air outlet valve. That's blowing air outside. That's the one that blows your beanie off. And we've got air conditioning inlet valve, so there may be occasion, which we'll talk about later on, where air will be required from the air conditioning system. And there's the cargo underfloor. Again, there may be situations where air is required from the underfloor. So all this is completely managed autonomously by the vent computer, so we don't really have to worry about it. There are temperature thresholds at which the configurations will be in either open or closed circuit. More of that a little bit later on. And there are conditions of whether the aircraft's on the ground or the thrust levers are at takeoff position. And if you want more information on that, and you're very good at reading and or not gates, you can have a look at that yourself and see what point the aircraft will be in which configuration. I'm not going to go into that much detail in this presentation because we just simply don't need to know it. What we need to know is basically how it works, why it's doing what it's doing, and what happens when we need to interact with it, what the switches do, and why we would need to do it. So looking at this basically then, and if we have a look here at the normal operation open circuit configuration, remember this is what you would normally see on the ground. Why is it open circuit configuration? Well, it's open because the skin air inlet valve is open and the skin air outlet valve is open. You'll notice the avionics bay, air conditioning and cargo underfloor valve are all closed. The blower van is basically blowing air in. It's basically sucking it in from the outside. It goes over and cools the avionics equipment. The extract fan then blows it overboard, and that's what blows off your beanie. Provided the skin temperature is greater than the ground threshold, and again you can look in the FCOM and see what those temperatures are if you're that interested, and you want that much detail, it's available. And you're on the ground and the thrust levers obviously be at idle, you will be in this open configuration. That's pretty straightforward, and that's where we would normally see the system on the ground. So the closed operation, closed circuit configuration. Now this is when the skin temperature is less than the ground threshold, or the aircraft is in flight and it's below the flight threshold. Again, I don't want to go too much into this, but essentially this is what you'll see when you're in flight, or in extreme circumstances when it's very, 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 very cold on the ground. The aircraft is in closed circuit. Why do we say it's closed circuit? Well, look, the skin air inlet valve is closed. The skin air outlet valve is closed, so nothing going overboard. Okay, so if it's an open configuration, the inlet valve is open, the outlet valve is open. When it's in closed configuration, inlet valve closed, outlet valve closed. But look what's happening here. The avionics bay valve has been opened up. The blower and the extract fans are still working. The avionics bay is conditioned.
and the skin exchange isolation valve is open, and you can see that the air is being imparted to the fluid, and then the whole cycle starts again. You've also got air coming in from the cargo underfloor, and it's all being heated and temperature managed, depending on the outside air temperature, of course, all via a closed circuit configuration. So this is how we would expect the system to operate once the aircraft is in the air. There's also one other configuration which is all part of the normal operation, as I call it, and this is the intermediate threshold, and this is when the skin temperature is greater than the in-flight threshold. Again, the temperatures you can see. So it's very similar actually to the closed circuit configuration. All the valves are in the sort of position that you would expect them to see, but look here, this is the skin air outlet valve is partially open. Now, you'll remember having a look at the outflow valve on the right hand side of the aircraft, the one that blows your beanie off. There's a little flap on the inside of it, and that allows that outlet valve to partially open. Okay, and that's really the only difference between the closed circuit and the intermediate circuit operation. Again, it's all temperature controlled and dependent on aircraft being in the air or on the ground. So hopefully that kind of explains the basics. Normal operation, open circuit, both valves open. Closed circuit, both valves closed. Skin heat exchanger operates. And then the intermediate configuration, same as before in closed circuit, but the outlet flap valve is partially open to vent that air overboard. Okay, good. So next we'll have a look at the abnormal configuration. Okay, so let's have a look at some abnormal situations then, and how and why we might need to intervene with this with the system. You'll have heard about vent and extract override push buttons. Blower and extract override buttons on the overhead ventilation panel. You've got blower, extract, and cab fans. There may be occasions when we would need to override when we get fault lights on here, and or there is smoke. Remember, there is smoke detection in the ventilation cooling system, or the ventilation system. So the reason you would get a fault light on here is if you had smoke, but essentially it's because the extract pressure or the blowing pressure is low. Perhaps the air density is low, perhaps the fan speed is low. It could be anything, but essentially the pressure is low. That's why you're going to get a fault light on there. Or the temperature in the ducting overheats, and as I say, if the smoke warning is activated. So if you get a fault light and you press the override switch, so let's say you have, if you pressed either of them, the system goes into closed circuit. Okay, so let's say you had a blower override. The system will go into closed circuit configuration, so that's the first thing it will do, and then it will add air from the air conditioning system into the ventilation. Okay, so the blower fan will stop if you press the blower override button. If you press the extract override button, it won't. The extract will always run, but if you get a fault light on there and you press override again, it will add air conditioned air into the system. So looking at the actual diagram itself and looking at the blower fault or extract fault alert, pressing either button will put the system into closed configuration. And remember what we mean by closed configuration: skin air inlet valve is closed, skin air outlet valve is closed, skin heat exchanger comes into effect. Now the blower fan is going to be turned off, because the fault light has come on, it's sensed low pressure. So to assist with increasing the pressure and or cooling the temperature because of the duct temperature, air condition inlet valve is going to be open. And that's really the only difference. When you press either one, it'll go into closed circuit and air conditioning air is added. Just remember, the extract fan, when you press override on there, the extract fan still runs. It says in the FCOM it's directly controlled by the switch. Well, go figure. I don't actually know what that means. All I can see is that it keeps running. Well, you need the extract to run, don't you? Because you need that to vent overboard if necessary. So one other configuration so I guess that kind of makes sense. The smoke configuration is slightly different. Now, if the smoke detector detects that there is smoke in there, you'll get a fault light on both the blower and the extract light. So the fault on both blower and extract light will illuminate. When both the blower and the extract push buttons are set to the override position, again, air conditioning system provides cooling air, which is then exhausted overboard. And at that point then, when both of them are off, the blower fan will also stop. Extract fan keeps running. So press the blower fan, override, it turns off. Press the extract fan, it'll still run. In both cases, air conditioned air will be added. If you get smoke, both lights will come on the blower and extract. You turn them, you press override on both of them. The blower fan will stop. The extract fan will keep running, and look what's happened here at the skin air outlet valve. It's partially open, and the idea of that then is to vent any smoke overboard. So there is a small opening there. I suspect that might be the flap in the extract door itself, partially opening to vent smoke overboard. And of course, adding duct air or air conditioned air into there because the blower van has stopped is simply just a way of adding weight into the air to try and clear any smoke that's in the system and dumping it overboard. If you get a controller failure, well, the system goes into the same configuration as above, except the skin exchange isolation valve stays open. So I guess it goes into closed configuration. The inlet valve and skin exchange inlet bypass valve remain in the position they were in when the failure occurred, so they just stop moving, and the extract fan keeps running. Battery in ventilation. The venturi in the skin of the aircraft draws air from the space around the batteries and vents it overboard. This resulting airflow ventilates the batteries. Well, that's pretty straightforward. And then, of course, you've got lavatory and galley ventilation. An extraction fan draws ambient cabin air through the lavatories and galleys and exhausts it near the outflow valve. And this runs continuously when electrical power is available. I can't add any value to that, to be honest, because I've just read that straight out the FCOM as I'm talking to you. So just before we wrap things up, take a look at the SD page for cabin pressurization. We've covered this in a fair bit of detail when we looked at pressurization in the other briefing. If you've not seen it already, I'll put a link up at the top here for you. But yeah, cabin press, we've got the delta P and VS and cabin altitude all obviously showing 0 at the moment. The aircraft is on the ground in this picture. We've got system 1 in operation. We've got the inlets and the outflow and the outlet valves both open, so the aircraft is in open config. The outflow valve is fully open as well, as you would expect on the ground, and of course the safety valve is closed. System 1 is in operation. Two systems obviously on the A320, and they alternate after landing. And we've got pack 1 and pack 2 both operating normally as well. So I think that really explains it. If you're happy, I mean, please do put any comments in the bottom if you need some further explanation on it. But I dare say if we go into this in too much detail, you're just going to overcomplicate it. It's actually a really simple system the more I look at it. We normally see it on the ground in normal open circuit configuration. In an out valve is open. Closed configuration normally in the air, or if it's super cold, they're both closed. Skin heat exchanger comes into force, and then it's in a closed system. And then of course, you know, if we're into intermediate configuration because of the temperature thresholds in flight, then the little flap opens up in the outlet valve to do a sort of an intermediate kind of setting. All this controlled completely autonomously for us. If we get a fault of the blower fan or the extract fan because the pressure is low, we press the button, turn off the fault light, goes into override, turns off the blower fan, and air conditioning air is added to the system, and it basically goes into closed config. And if we have smoke, pretty much the same deal. Air conditioning air is added, and then there's a partial opening of the extract valve in order to dump the smoke overboard, with air conditioning air coming in to help force it out. Job done. Good. Okay, well, that was better and simpler than I thought it was going to be. I hope it has been the same for you. Thanks for listening in, and I will talk to you again soon.